Okay, guys, our next topic that we are going to cover is about chemical reactions and balancing chemical equations. So you know what I've been saying, especially for that second half of the year, in chemistry, it's not a learn it and lose it, it's a learn it and know it and add a little piece on. So what we're going to do is take all those chemical formulas that you've gotten really good at writing, and we are going to put them together and look at what happens when we combine or break apart some of these compounds in a chemical reaction. So we've done a lot of labs, and I'm bummed and hoping we can get back to school to do a few more, but there are some signs that tell us that a chemical reaction is taking place. We could see a change in color. We could see a change in the consistency, a solid forming where we may have started with liquid. We could see or detect a change in smell, the release of a gas, and we definitely saw that in some labs we did in the beginning of the year when we saw bubbles being produced. Energy changes can take place. This can be the absorption or release of light. If you've ever played with glow sticks, that's an example of a chemical reaction that releases light. And we did see in some of the labs that we did a change in temperature or an absorbing or releasing heat, where you are directed to feel the bottom of a well plate or a test tube and you notice that it got hot to the touch. That's an example of an exothermic reaction where heat was released. The reaction could also absorb energy from the surroundings and the temperature could decrease. That would be an endothermic reaction. And you can see that there are some signs of chemical reactions, and those are just depicted right there in the picture off to the side. So we have a way, we use chemical equations to represent or model what's happening during a chemical reaction. In a chemical equation, we can either represent what's happening in words, or we can replace those words with the correct chemical formulas. If we are using chemical formulas, we have to remember our rules for writing correct chemical formulas. If it is an acid, we just have those written right on our periodic table. If it's a diatomic molecule, there are 7 of them that always come with the subscript of 2 when they're by themselves. If it's an ionic compound, it's a 2-step process. Remember, in ionic compounds, the net charge is 0. So we have to write down the charges, look at the charges, and then figure out that chemical formula. If it's a covalent compound and it's made of only non-metals, then we will use the prefixes to figure out the correct subscripts and to write the chemical formula. At the bottom of the page, I've written down for you some examples of chemical formulas. Okay, that took a second. So there are some word equations and chemical equations, an example at the bottom. In the word equation, I'm telling you that sodium is reacting with chlorine to make sodium chloride. So sodium and chlorine are the reactants. Those are my starting substances, and they're going to produce something new when they come together, and that new substance is called sodium chloride. We saw this in the Hunting the Elements video, and we watched the guy make salt for his popcorn. If I replace those names, sodium and chlorine and sodium chloride, with the correct chemical formulas, I end up with a chemical equation. So sodium, I'm going to replace the word sodium with the element symbol for sodium, Na, and I'm combining it with chlorine, so I'm going to put a plus sign because I'm adding them together. And chlorine is one of my diatomic molecules, so I'm going to write Cl with a subscript of 2. And then my product is sodium chloride. So the product of sodium chloride is an ionic compound. So I had to write down my charges to figure out the correct chemical formula. Sodium has a +1 charge, chlorine a -1 charge, and I balance those charges to get the chemical formula of NaCl. You'll also notice that there are 2 large numbers, 2 in front of Na and 2 in front of NaCl. Those are called coefficients, and we use those coefficients to balance the chemical equation. The starting substances in a chemical reaction are called reactants. Those are the materials that I start with and that are going to combine or react together. They're always represented on the left side of the arrow. The new substances that are formed from the reaction are called products, and they're written on the right side of the arrow. In our example at the bottom of the page, Na and Cl are my reactants. That is what I'm starting with, and they're on the left side of the arrow. NaCl, or sodium chloride, is my product, and it's on the right side of the arrow. If there's more than one reactant or product, remember they're separated with that plus sign. Na and Cl are separated with plus signs. And the arrow again shows us where the products are. There are some signs and symbols that we'll see as we look at chemical equations. So the plus sign we talked about, that's going to separate reactants and products when there's more than one of them. And the arrow is showing us the direction of the product. We saw some letters S, L, and G in that chemical equation. That just tells us if the substance is a solid, a liquid, or a gas. A new symbol, AQ, is called aqueous, and that tells us if a substance is dissolved in water. Sometimes there are some symbols that are placed over the arrows that indicate if something else is involved in the reaction. Maybe the reaction needed a little help to take place. So we could add heat, a little thermal energy, or we might need to speed up a reaction. A catalyst is a substance that will help speed up a reaction that maybe would take a really long time. So those are some symbols that we will see in our chemical equations. In a chemical equation, we need to make sure that we understand that chemical equations don't create new matter or destroy existing matter. That's the law of conservation of mass. Atoms can't turn into other atoms. They can change who they're bonded to, but we have to start and end with the same number and types of atoms on the reactant and the product side. So after we've written a chemical equation, we need to analyze it and balance it to make sure that our chemical equation doesn't make it seem as though we've created any elements or destroyed any elements in the process, because that's not what happens. So we balance the chemical equation. If you look at this example, this is called a decomposition reaction. We're starting with silver oxide, and silver oxide is breaking down into the elements that it was made of. It's breaking down into silver and oxygen. But on the left side, if you notice, I'm starting with two silvers. There are two blue spheres to represent the silver and a brown sphere to represent the oxygen. So on the left side, we're starting with two silvers, but ending with only one. It looks as though I destroyed a silver. On the right side, I'm ending with two oxygens where I started with only one. So it looks like I've created some oxygen. When you look at the bottom of the page, you'll notice that what has been changed is the coefficients. There is the number 2 in front of silver oxide and the number 4 in front of silver on the product side. So now those coefficients have helped us to balance the equation. This is like our recipe again, which helps us identify what I need to start with and what I will end with. When we balance a chemical equation, we'll first start with writing the correct chemical formulas and then get a count of the atoms of each element on the reactant and on the product side. After that, we are going to add coefficients, those large numbers that we place in front to balance the chemical equations. We want to make sure that those coefficients are in their lowest possible ratio. The coefficients in this example, the 2 in front of iron 3 oxide, the 3 in front of carbon, the 4 in front of the iron, and the 3 in front of carbon dioxide. Those are all our coefficients. We're also going to look at some types of chemical reactions, see if we can figure out what's happening during the reaction. Some of the different types of chemical reactions that we'll look at, the first one is synthesis. This is when two or more substances combine to make one product. So we start with two reactants and we end with only one product. The second is decomposition. This is when we start with one reactant and it breaks down into parts. We end up with more than one product. The third is a single replacement reaction. One element switches places with another. So you can see in the equation to the right for that, A and B are together when the equation starts on the reactant side, and C is all by himself. After, on the product side, A has been kicked out all by himself, and B is now partnered up with C. The last example we're going to look at is a double replacement reaction. And this is when two elements and two compounds both switch places. So this is a double swap. So when the reactant side, we have A is partnered with B or bonded to B, and C is bonded to D. On the product side, A is now with D, B is now with C. And there is one more type of reaction called a combustion reaction. And this is when a substance rapidly combines with oxygen to form carbon dioxide and water. Here are some examples, again, and just some explanations of synthesis, decomposition, single displacement, double displacement or replacement, and combustion reactions, just to give you an example of each one.